Hey guys, as promised, the second part of the PowerPoint is narrated by moi. I like the physics part of this unit, and there's a lot to learn, so let's get started. So we are still on motion, and now we're doing speed and velocity. So after today, you will be able to perform your calculations using speed, distance, and time. You will be able to figure out what the average speed of an object is, and you will be able to identify and create a graph illustrating motion. So speed is the rate of distance over time. Ratio and rate are kind of the same word. So it's the time rate of change of the distance of an object. An average speed is for an entire duration, or like however long you're going, that's where your average speed is. Instantaneous speed is just right at a second. So in order to calculate the average speed, you take a total distance over the total time. So here's a practice problem. I want you to pause this and write it down and see if you can figure out average speed if you travel 35 kilometers in 0.4 hours and 53 kilometers in 0.6 hours. What would your average speed be? Now pause it. I'll wait. Welcome back from your pause. So if you have a distance and a time and another distance and a time, and you know that your average speed is your total distance over total time, then the steps you take to solve this problem are you find the total distance by adding 35 kilometers plus 53 kilometers to get a total distance of 88 kilometers. And then you add both times. Total time is equal to the first time times the second time, plus the second time. So it's 0.4 hours plus 0.6 hours. And then you put the total distance in this spot and the total time in this spot. Notice that I never dropped off my units. Numbers without units, we don't like them. So your average speed is 88 kilometers an hour. Not too shabby. Instantaneous speed is like for just a second, one little second of time. So if you're getting a ticket, you're not getting a ticket for your average speed. Officer doesn't care what your average speed is for a whole trip. They're interested in your instantaneous speed, and that's why you got to watch your speedometer. Okay. When you see a distance versus time graph, when you see a graph, a motion graph, you always look at the axes. And here are two examples of distance time and velocity or speed time graph. The only difference between velocity and speed is direction. So everything is the same about both these graphs except for that part right there. But if you are speeding up, if your velocity is changing here, you have a changing slope, because the slope, which is the most important thing to remember, the slope on a position time or a distance time graph is the speed. So right here, the slope is constant, so the speed does not change. So velocity is the speed and direction an object is traveling. Velocity is a vector. That means it has components in both directions. That means that you have to talk about direction when you talk about velocity, because it's a vector. Vector means direction. Remember that if you know the start and the end speed, you don't get the average velocity by averaging these two. Velocities are vectors and directions matter. So a cheetah can run 60 miles per hour. There's an antelope 30 miles away. How long will it take to reach the antelope? This is more of a thought problem, right? If you can go 60 miles an hour, how far do you go in 15 minutes? It's real easy. It's a mile a minute. So if it's 30 miles away, then it's just 30 minutes. That one's the one I can always remember. So let's talk about relative velocity. When you have velocity of something in something else that's moving, remember when we talked about the mouse on the train car, perhaps? You have multiple velocities. So here is this boat. You can see that the current is going the same direction as the boat. So even though the boat might be thinking it's going a certain speed, it's also going the speed of the river. When you are in a boat and you have to go against the current, you know that your motor's going to have to work harder. That your speed relative to the shore is going to be the speed of the boat minus the speed of the river. So let's take another look at that. If the boat is going 5 kilometers an hour downstream, which is with the current, and the river is flowing at 12 kilometers an hour, the resultant velocity is 17 kilometers an hour downstream. Downstream is the direction, and 17 is the magnitude or the amount. Okay, the distance is 17. You got to say what direction. I'm sorry, the velocity is 17, but you got to say what direction. If the boat is trying to go against the current, it's trying to travel the opposite direction, okay? The river's still going downstream. It's going in the same downstream, just means in the direction of the current. So the river's flowing, and then the poor little boat is trying to get upstream, but it can't. It's still going downstream because it doesn't have enough velocity to counter the river current. If you just think about what's going on, the resultant velocity is still, the boat is still going to be going downstream. Okay, so let's say if you had a boat that was trying to cross a river, okay, it's not going to get to go straight across the river unless if it heads that way. So it says, I'm going to go straight across this river at 12 kilometers an hour, but the river is going 5 kilometers an hour to the right or perpendicular. The way that you can find that is to use Pythagorean theorem, which is a squared plus b squared is c squared. You're going at a right angle to that river, and to find how fast you're actually going, you use the Pythagorean theorem. Okay, so you will have a ticket out. It will be on the web page, and I hope that wasn't too difficult. Y'all have a lovely day.